So yesterday, we started looking at how to calculate a problem with a horizontal projectile. So what I'd like to do right now is just go through the notes that we took yesterday, so you can revisit these if you ever need help going through one of these types of problems. So here's the worksheet from yesterday. The first part goes through the steps to solve a horizontal projectiles problem. So okay, so the first thing that we're going to do is make an XY chart. So just to review, make sure my pen is working. So just to review, Y is your vertical, is up and down, and X is horizontal, and it's left and right. Okay, so we're going to make an XY chart because this projectile, a horizontal projectile, is traveling both down and left and right. Okay, so the first things that we're going to put in our chart are the three knowns that we have. Okay, so the first thing that we know, if we have a horizontal projectile, okay, we know that the first thing is that in the X direction, there's no acceleration. So over time, this projectile is going to travel the same velocity over time in the X direction. That will not change. Okay, because there's no forces acting on it in the X direction. Okay, but we know that vertically, in the Y direction, gravity is pulling down this object and it's causing it to increase its speed. So initially, it just has a horizontal velocity, but then gradually, vertically, it's going to start increasing its velocity, okay, because it's being pulled down by gravity. So that we know the acceleration in the Y direction is negative 9.8 meters per second squared. Okay, so initially our projectile is a horizontal projectile, okay? So it only has a horizontal velocity to start, okay? It's not launched up in the air. So we know our initial velocity in the Y direction is always going to be 0 because this is a horizontal projectile. So these three things we always know and can put in our XY chart to start. Okay, so I'm going to scroll down, okay, and start and give you an example of how to solve one of these problems. So a stone is thrown horizontally from the top of a 78.4 meter high cliff with a speed of 5 meters per second. How long does it take the stone to reach the bottom of the cliff? And how far from the base of the cliff does the stone land? So the first thing is to just visualize the problem, okay, to just make sure that you know that it's a horizontal projectile. So we have a stone, okay, it's thrown horizontally from the top of a cliff. So we know that it's going to follow a parabolic path as it falls. Okay. So anytime we have an object that's traveling down and forward, right, we know that it's a projectile and we need to make an XY chart. So there's several things from above that we automatically know, and that was these three givens. We need to place those in our chart. So we know in the X direction, our acceleration is 0 meters per second. Okay, we know in the Y direction, it is negative 9.8. Okay. We also know that our initial velocity in the Y direction is 0. Okay, then I'm just going to put in all the other variables that we know or could possibly solve for. Okay, and then we're going to just read the problem and put everything in. So it says a stone is thrown horizontally from the top of a 78.4 meter high cliff with a speed of 5 meters per second. Okay, well, I know 78.4 meters high. Okay, I know according to my units is distance, but I need to decide which distance. Well, it references height. Okay, so anytime they reference height, or how high, we know that that is dy. It is vertical, okay, because it's talking about how high someone is or how tall. Okay, so we're going to put that in 78.4 meters. And our object is dropping that far, so I'm going to put a negative in here. Okay, then it's thrown with a horizontal velocity of 5 meters per second. The only speed that I have left is my horizontal. Okay, and then the question's asking how long does it take the stone to reach the bottom and how far from the base of the cliff does the stone land? So the remaining things are all unknowns in my problem. So now what I'm going to do is I'm going to solve for how long the time, I'm looking for time, okay, so how long the object has been in the air. So I'm going to pick which side has the most variables. So on the x side, I have two unknowns, so I can't use that side. So I'm going to go and use the right side. I'm going to use the y side. Okay, and I also forgot, we have VF, right? But it mentions nothing about final velocity in any of the problem, so I'm just going to cross that out. Okay, it doesn't mention anything about final velocity. Okay, so the equation that I'm going to use is d is equal to VIT plus 1/2 AT squared. Okay, and I'm going to plug in everything on one side. I can't mix and match. Okay, so because I'm finding how long, and I know most of the stuff on the y side, and I only have one unknown on the y side, I'm going to use everything on the y side to solve. So I'm plugging everything in, negative 78.4 equals, now VIT, this whole thing is 0. Anything times 0 is 0. I'm going to get rid of it. Plus 0.5, A is negative 9.8, and t squared is what I'm solving for. Okay, so this is 0, it goes away. I'm going to do 0.5 times negative 9.8 is negative 4.9 t squared. Okay, the negative 4.9 is being multiplied by t squared, so I'm going to divide both sides. So t squared is equal to 16. Okay, then to undo the square, I'm going to take the square root. So t is equal to 4 seconds. Okay, now once I know that, okay, that information will now become unknown in my chart. Okay, so I know 4 seconds is what I solved for. So I'm going to put that in my chart now because that's something that's given. And time goes on both sides because there's not a special type of time. It takes the same amount of time to fall as it does to go forward, okay, for the marble or the stone. Okay, so now time is in there and it's on both sides, and now I can use it as a known. Okay, so what I'm going to do next is I'm going to solve for B. How far from the base of the cliff does the stone land? Okay. So it is now referencing how far. Okay, so vocabulary words, we know that height, how high, how tall is dy. Okay, so our vocabulary words, how far, how far is going to be dx. Okay. So these things are very key to know those vocabulary words. So how far is dx, how high is dy? So what we're going to do is we're going to use the same equation. Okay, we're going to use d is equal to VIT plus 1/2 AT squared. But this time I'm solving for how far. So I have to use everything on the x side. I can only plug in information on the x side. So I'm going to look at, we're trying to find how far. My VI is 5, according to my X side, and my time is 4. Then I'm looking at plugging everything in. So 0.5, my acceleration is 0, and my time is 4 squared. So 0 times anything is 0. So this entire term right here goes away, and all I'm left with is 5 times 4, which is 20 meters. Okay, so it is a lot of steps, okay, but you can revisit this video if you need help on the steps needed to solve.